If minus V saturation, it will discharge. That is the story of this mechanism. Okay, capacitor can charge and discharge. If suppose the answer changes to minus V sat, suppose if the answer is changed to minus V sat, then automatically this capacitor, whatever it charge, it will try to discharge. So one is charging, one is discharging. This is called charging when you are at plus V sat. When it comes to minus V sat, it will try to discharge. This concept is called as free running oscillator. Now today we will see charging, discharging, how it will move in the waveform. Okay, this is a very simple problem, simple concept I can say. When the output becomes plus V saturation, the capacitor will charge the value. When the output changes to minus V saturation, it will try to discharge. Yes, both what you are telling is a good answer. Maybe in digital electronics you have seen a NOT gate wise we can make oscillators. Correct? S-stable we can do it, bistables we can do, monostables by using NOT gates. Maybe there you have studied a odd number of NOT gates are there. Correct? Odd number of NOT gates. When you are studying, they can work like oscillators there, S-stable multivator techniques. NOT gate also we can use it. So how this plus to minus to plus is changing? That is the point you have to understand in the waveform today. Nothing to explain, waveform will explain the concept. Plus to minus to plus. Due to negative offset, then does the capacitor charge for minus V sat? The others here, I am not applying offset negative positive, I am applying positive only, but answer will change. How it is going to change? I will show you the waveform technique now. Only one offset only I have given, but answers will change plus to minus to plus because of capacitor. A capacitor कैसे change करते हो? Previously signal is changing plus to minus to plus. Now capacitor will change it. Okay? How it is going to change? Let us see. The concept. In the next page, in the next slide, you can see the story. This is the story. This is your output. We have two boundaries here. One is beta V sat, one boundary. Another one is minus beta V sat. Now capacitor started charging from here 0. Initially the capacitor is 0. It started charging like this. Up to beta V sat, the capacitor started charging. Okay. When the capacitor is charging, how much it can charge is up to plus V sat it can charge because you have given plus V sat to RNC component. But it is charging up to beta V sat. But my Smith trigger is telling that when you touch the trigger point, the capacitor reaction will change opposite. Why? Because when you touch this point, the output will change to minus V sat. Positions will change. So it can charge only up to here. But really speaking, if there is no Smith trigger, I think happily it can charge up to plus V sat. But we kept a Smith trigger here. What trigger is there? Because of the trigger, automatically your output goes to minus V sat, such that at this point the capacitor will try to discharge it. So this is the meaning I said. When you cross the trigger, the output will change. When the output changes, I think your trigger will change, so that the capacitor will discharge because of minus V sat. Okay. And again, I think if there is no Smith trigger, it can happily discharge up to minus V sat. But it is only stopping here by the comparator. This comparator is stopping there. Again, when you touch this point, the output will become plus V saturation. So capacitor will try to charge it again up to this trigger point. But it can happily charge up to plus V sat. But it's not charging. Again, when it touches this point, it will try to discharge. Can you see that? Inside your circuit, this is the mechanism going on. It is just charging, discharging, charging, discharging, charging. This means no state is stable. It's unstable states. Okay? So this simple mechanism, we call it as a stable mechanism. I have not taught anything in this lecture. One RNC component, why we have used, I said the point, capacitor is charging, capacitor is discharging. When output is plus V sat, minus V sat. Second point is Smith trigger. Smith trigger, I joined it. When there is two triggers, the capacitor will try to change the outputs. If plus V sat comes, it will charge. If minus V sat comes, it will discharge. That is the beautiness. If you know Smith triggers, they're all easy things to learn. Okay? Now let us see the output, how to write for this. How to write output? When it is charging, up to here, it is charging. And up to here, it is discharging. And again, up to here, it is charging. So whenever it is charging, this value, the output will be plus V saturation at the time. Whenever the capacitor is charging, your output will be plus V sat. But whenever it is discharging, at that time, my output will be minus V saturation. So can you see a square wave is generating by this capacitor action? So again, when you are charging, it will go to plus V saturation. Again, it will go to minus V saturation. So this is the way how we got a square wave by this capacitor action. So inside is capacitor action, outside is square wave output by the output result. So when you have charging, the output will be plus V saturation. When the capacitor is discharging, the output will be minus V saturation. So it is easy to confirm the graph. You can take this as a TC time period, and this is a TD time period. So better take not here TC, you take here TC. Initial value to origin. This is a discharging time, this is charging time you can take. Now I can write a point here. What is the point is? When capacitor is charging, when capacitor is charging, your output is equal to plus V saturation. When capacitor is charging, at the time your output is at plus V saturation. When capacitor is discharging, your output will be minus V saturation. So this is the principle behind your stable multivibrator. Okay, this is your discharge. Yeah, Samresh, if it's a DC source, we say linear charging and linear discharging. If it's a AC, we consider linear discharging. Okay, this is a linear charging and discharge. Okay, because whenever DC sources are there, we can say that both linear charging and linear discharging. We can say linear discharging and linear charging here. This is a small principle. Okay, it's not a very tough topic. Examiner, what he will ask is important. In these questions, what he will ask is the total time of oscillation. They'll ask you charging time how much, discharging time how much, frequency of oscillation. These things we have to find out. One important formula I create for you is small derivation. So suppose if I take a standard formula, capacity formula, Vc is equal to V final plus V initial minus V final into e power minus t by Rc. I already told you this formula will help us to solve the capacitor problems, charging discharging problems. It helps a lot actually. It helps a lot. This formula will help a lot today to do the problems. Vc formula is V final plus V initial minus V final into e power minus t by Rc. In my class only, so many times we have seen this formula when I'm teaching capacitor questions. So one time practice this formula, we'll apply it now. So if you want to solve TD, TC you can solve because it's a symmetrical square wave. So whatever you solve here will be same here. So you take any one condition to solve it. Both are same here. So if I take a condition, suppose T is equal to TD I am taken. That means I'm finding my time period here. T is equal to TD. At that time, what is the initial? See, what is the initial for this one? This is your discharging. Okay, where is initial for this? Where is final here? It means this point will become your V initial value. You just write in the notes. This is initial value when you stop. And where is final value is this one. This is V final. You have to reach actually up to minus V sat. This is the final. And actually you stopped here, which is a VC voltage. This is your VC. So like, where is initial, where is final, and where is VC? 3 points I got in the board. Okay? 3 points. This is initial, this is final, and this is VC. So let us apply it. It is a VC means minus beta V sat is equal to, this is minus beta V sat, VC. V finally is minus V sat plus V initially is beta V sat minus of minus plus V sat into e power minus TD by Rc. So everybody can do this derivation and you can solve the TD value. It's not a big derivation. Just formula you have to know, graph limits you have to know. So I think I substituted nicely all the values. Diagram. So let us apply the common terms. V sat comes here. It becomes 1 minus beta V sat is equal to 1 plus beta V sat common into e power minus TD by Rc. V sat will be cancelled. Then e power TD by Rc, if we bring this side, it will become 1 plus beta by 1 minus beta. E power TD by Rc is equal to 1 plus beta by 1 minus beta. Then TD formula if you want, apply the logarithmic to get this answer. The derivation is completed. The derivation is completed. If you take logarithmic on both sides, it becomes TD is equal to Rc ln of 1 plus beta by 1 minus beta. So this is the formula of TD. So according to square wave, this is square. In square wave, I think TD and TC will be same. So the formula will be Rc ln of 1 plus beta by 1 minus beta. So square wave wise both are same. Charging and discharging will be same. So what will be the total time period here is? Total time period is, it is 2 times of Rc ln of 1 plus beta by 1 minus beta. So this is the most important formula to solve this type of questions. Very valuable formulas these are. 2 Rc ln of 1 plus beta by 1 minus beta. Number of times this question came, just to form this and निकल सकते problem सबको. Okay? 2 Rc ln of 1 plus beta by 1 minus beta. So frequency of oscillation if you want, it is 1 by reverse of this answer. This is your frequency of oscillation, where beta is R1 by R1 plus R2. So these formulas are the best formulas in stable techniques. Have a good practice. Have a good practice about these formulas. It will help a lot to solve this type of questions. And this separate formula, TD also have a practice. TD and TC formulas. These problems. So hardly it's a matter of understanding about the formulas. Okay. So this completes my a beautiful topic in electronics called a stable multivibrator is covered only by 2 common sense points. One is capacitor charging, one is capacitor discharging. Okay. Why it is called free running oscillator means capacitor freely charging and discharging by itself. It's a linear charging is going on. So oscillator. So let us have, I think we'll take a break now. It's 1:10. So around 2:15 we'll meet again. 2:15 से start करते. What are the remaining topics we'll try to complete? Suppose 4:30 or 5 we'll see according to the class. By chance if I okay today if it is not completed that last topic, 8th topic that is called what is a voltage regulators special topic. We'll include the topic for tomorrow morning class. Okay, because it takes some time to teach. Maybe I'm expecting today I complete up to that bistable multivibrator will complete. If 8th topic is not completed, don't worry. Tomorrow morning we'll extend freshly the topic I'll explain. 8 to 8:30 to some 10 o'clock I'll cover that module. So 10 से हम वर्कबुक practice start करते. Okay, after workbook practice we'll go to the negative feedback amplifiers. Otherwise tomorrow what we'll do is first we'll complete the negative feedback amplifiers, then we'll start the workbook. Tomorrow we'll decide that. First topic first we'll start our workbook and tomorrow we'll decide that. Anyway, tomorrow 8th topic I'll complete. So today I think we have only 4 topics I have to cover now. After the break, that is one is triangular wave generator after this class, and one more we have is sawtooth. These 2 things will be covered immediately. After that we have 2 topics. One is monostable and one more is bistable. Suppose the class is completed by 4 o'clock, I'll stop at 4 o'clock for you. 4:30, 4:30. Okay. If it is 4 o'clock completed, it's happy for you. 1 hour you can have relaxation. Okay. We'll cover this tomorrow. We'll see that one. And one more conclusion I think I missed for you. Just tell you that conclusion. Small conclusion is missing. Conclusion is missing. So one thing we'll do here, conclusion what I'll do is 5 minutes before only you come to the class, where in the board I'll write that conclusion without the wastage of time. You can write that conclusion. Okay. Now I'll leave, I'll take break. I'll write the conclusion which is for the split trigger writing. The conclusion I'll write in the board, you just copy it. You'll understand it. What is the conclusion I said? The simple conclusion here is just orally first I'll tell you. A closed loop comparator is better than a open loop comparator is telling. A closed loop comparator is having some loop is coming. Have you observed? Hysteresis loop. That loop is telling that any noise enters inside the loop, it will reject it. Noise it will not allow. Therefore, but in previous case, at 0% of noise, I think it became unstable. Because of that noise elimination loop, whatever may be the noise you disturb, the circuit will not understand it. It will understand only the trigger points. Okay, and inside whatever may be the noise comes, it will not disturb it. This conclusion I'll write in the board. Before 5 minutes you come and copy.